last week, and then we're going to continue forward because your assignment was only the first part of 7.4. And so we're going to pick up the second part of 7.4 plus 7.5 and 7.6 this week. So the first thing that you need to recognize is when you have polynomial fraction, which is called a rational, rational or fraction, whenever you have a polynomial ratio, you are not allowed to have zeros in the denominator. For what reason? Why?
Because it you come out undefined.
Right. Division by zero is undefined. So this tells us that x cannot equal -1 and x cannot equal +3. Otherwise, we have division by zero. Now, we are going to be learning factoring of polynomials. And when we factor this polynomial into these two binomials, what happens is these two numbers will these two binomials will end up canceling. And so the actual equation that you're going to be graphing will be 1 over x plus 1. Right? The difficulty is that x could not equal 3. Now, whenever you have 0 over 0, that is called a discontinuity. It used to be called a hole. Because there's a hole in the graph, you're not allowed to have x equal 3. So there's a hole in the graph where x is 3. Whenever, if there's only 1 in the denominator, this becomes an asymptote. So you're going to have a vertical asymptote at -1. You'll never cross that line. And then you're going to have a hole at 3 because you cannot have x equals 3. Right? Does that make sense? All right, and it's harder to see here, but that's the definition of the hole. All right, that's the reason why we used to call it a hole instead of a removable discontinuity. Okay? All right, now that's the first part. All right, polynomial factoring. There are several kinds of polynomials that you are supposed to be able to factor automatically. All right, so I'd like you to get some notes or get a note paper so that we can talk about these. But these are things that we should have done last week, and we're going to go back over them. All right, first of all, this is called difference of squares. All right, if you have a difference of squares, first of all, difference means subtract, and I hope you knew that. Right? If you have a difference of squares, you end up with a vocabulary word called conjugates. Conjugates. Conjugates have the same values but different signs. So, I gave you a really weird one. 49x squared minus 64. Are 49 and x squared, are they both squares? Yes. Is 64 a square? So therefore, this negative sign means we have a difference of squares. So I'm going to take the square root of the first term and the square root of the last term, one positive, one negative. It turns out that the square root of 49 squared is just 7x. Right? Square root of 64 is 8, so this becomes 7x plus 8, 7x minus 8. All right, you must be able to factor those difference of squares, and then what's going to happen is, in your rational, you'll have the difference of squares on one side, and then you'll have a factor that's a binomial of one of these two, usually, on the other side that will cancel out. Okay, so that's the reason for knowing that. Okay, now, for Algebra 2, you also have to know the sum or the difference of cubes. Whenever you have a cube of a number and a cube of a number, you're going to have the same sign and the cube root. Then you will have an additional polynomial that will have the square, so that what is x times x squared? It's x cubed, right? What on the end, what is y times y squared? It's y cubed. And in order for the other values to zero out by subtracting, if this is plus, this is minus. If this is minus, that is plus. And do you notice that what this is these two numbers multiplied together. Alright, so here's an example. 64. Alright, you know, you should memorize what's 2 cubed? 2 cubed is 8. You need to memorize that. 3 cubed. 27. You need to know that. 4 cubed. 64. 5 cubed. 125. 6 cubed is 216. You should know all 6 of those. Count the one cube. Right? Please learn that. It will make life easier for you. Because you won't have to stop and figure out what it is. You'll know what it is. You already know these on squares, right? You should learn the first 6 cubes as well. Alright, so 64 is 4 cubed. So when I do that, I'm going to have, well, where'd it go? Did I finish it? Yeah, this is going to be the cube root. I see what I did. Let me bring this down just a bit. Alright. This first number is the cube root of this. Alright, what's the cube root of 64? It's 4. So this will become 4x. Right? Because that's plus, this stays plus. 27 is what value cubed? Say 3. 3 cubed is 27. Say it.
3 cubed is 27.
Thank you. So when you have this, the cube root will be 3w. Now, we have to square 3w and get 9w squared. We square 4x and get 16x squared. Right? The 4 times the 3 will be 12xw in the center. Right? You've got to be able to do that. Now, factoring completely, see this 8 and 18? What's the common factor? Common factor is 2. If I put x cubed and x here, we could have also had a 2x. And then I have this. But what is that? Everybody say difference of squares. So how does this factor? That's what you got to know. X plus 3, x minus 3. So this will become 2x plus 3x minus 3. That's called completely factoring. Okay? Now, one of the things that the book tells us is that if you're not sure whether or not a trinomial can be factored, do the discriminant, b squared minus 4ac. If b squared minus 4ac is a perfect square, then it will factor. Because it will be negative b plus or minus some perfect square. All over 2a. Okay? Now, alright, this is the harder part. Whenever you have a polynomial where the first number is not 1, you have to factor both sides. So this 20, which is 4 times 5 or 2 times 2 times 5, this 20 has to be split. Let me see if I can raise this up here. Whoops. Oh, where'd it go?
We closed it.
Okay. I wanted to do this. That's a minute. Oh, I killed the whole thing, didn't I?
Yeah.
Alright, I can handle that.
Naomi, you're all by yourself.
It's because I'm just like over the camera.
Yeah. Alright, here we are. Okay, is that going to do it? Yes. Okay, so 20 have to go in the first part of this binomial or the first part of this binomial. The factors of 18, which is 2 times 3 times 3, has to go in the second part, and together, when you add the two inside and outside, you have to come up with a total of 39. All right? And what happens when you have a large value polynomial is you are actually guessing and checking. All right, now, because this is plus, I'm going to add the factors and end up with positive 39. All right, so if I use 20 and 2, I'm already over the 39, so it can't be 20 and 1 and 2 and something. So that means that this 20 is going to have to be broken down. And so the first thing that I tried was 4 and 5. Because 4 times 5 is 20, right? So that'll make this 4x and this 5x. Now, because I didn't know, I said, well, let me try 3 and 6. And when I do that, I have 15 plus 24, and I happen to get it on the first shot. Because 15 plus 24 is 39. And so that means that I have 4x plus 3 and 5x plus 6 as the two factors, the two binomial factors of that trinomial. All right? There is no simpler way to get those binomials. Okay, there is no simpler way. Yes?
I worked it out the same way by splitting the middle term.
That's what this does.
Oh.
That's what that does.
Okay.
Right? But splitting the middle term is another, what would you split it into would be the question. See, because the first numbers have to be factors of 20, which is either going to be 1 times 20, 2 times 10, or 4 times 5, it's simpler to work off the factors of 20 and the factors of 18 in a guess and check. But you're actually doing the same thing because this is the split. Okay, so you know, if that makes sense, you can use it. This is a little faster. Okay, all right. Okay, question on that one. All right, so let's move to another one. Okay, let's see if I can do that. All right, so here, what are my factors? The factors are factors of 30 and factors of 50. Well, 30 is 6 times 5, and 50 is 10 times 5. So I have to split 2, 3, and 5 somewhere in the first term, and I have to split 2, 5, and 5 somewhere in the second term. The total has to be 95. Okay, so what are you going to try? To get to 95, if I don't have some big numbers, I'm not going to end up with 95 very easily, am I? So it turns out that this try is 15 and 2 for 30, and then 10 and 5. All right, what is 10 times 2? 20, that's the 20x. 15 times 5 is 75, and the two of them add up to 95. Now, so this becomes 15x plus 10. Now, here's something you have to recognize. See those original numbers? Those original numbers all have a factor of 5 in it. What would happen if I had taken the factor of 5 out first? The numbers would have been smaller and it would have been easier to use. Okay. So let's look at that. If I take the 5 out, I have 6x, 19, and 10. And so now I want factors of 6, which are 2 and 3, as well as 6 and 1, and then factors of 10, which is 2 and 5, 10 and 1. And we're going to do the same thing. How do I get a total of 19? Well, this can be 3 and 2, and this can be 2 and 5. I'll have 4 plus 15 for a total of 19. That's how they work. All right, now, we'll do one more. Okay, 18 and 10. All right, the common factor is 1. All right, so I'm going to use these regular numbers. What are the factors of 18? 2 times 9, but 9 is 3 times 3. And the factors of 10 are pretty simple. All right, and so now the question is, how do I get a total of 27? All right, you try it. You try it. What do you want to try first on this split? Anybody want to guess?
6 and 2.
All right, that sounds good. How about we'll put a 6 here. Woo. A 6 here, and we'll put a 2 here. All right, what about for the 10? Now, if I put the 5 here, I'm going to have how much? 5 times 6? 30. That's going to be too much, isn't it? So I might as well try the 2 here and the 5 here. Now, what happens? How much is this? 2 times 6? 12. So this is 12, and this is 10. Total is 22. Doesn't work, does it? Okay, so that means we have to try something else. So if I can't use 6 and 2, how about you? Wait a minute, I'm sorry. It was 6 and 3. So that will work. 18 and 10 is how much? 28, right? Okay, so that doesn't work, so we've got to try something else. All right, you see this right here? It's a odd number. In order to have an odd number, I have to multiply 2 odd numbers together. So that means it looks like that the 5 and the 3 need to go together. Now what's left to get 18? 3 times 6 and 5 times 2. And now I have 15 plus 12, which is 27. Okay? Now, sometimes the first time you get it, it'll be right. Sometimes it will not be right. Okay? And so this becomes 3x plus 2 and 6x plus 5. All right, question? Now, that's more of the same. Okay. Now I did this last week with my group, and I call this offset multiplication. Whenever you have 2 polynomials that you're multiplying together, when you multiply 3x cubed times x squared, you get 3x5. Right? And when I multiply 3x cubed times 4x, I end up with 12x4. Alright, that will go down. But when I go to the second one, negative 2x squared times x squared is negative 2x to the 4th. I don't put it down here, I move it over 1 so that the x4s are lined up. Right? And then I'll finish that out. And then when I go 5x times x squared, that's 5x cubed, that'll end up in the cube part. And then these offset will all line up so that your like terms are in the same column, which makes the answer much easier to find. Okay? The other alternative is to make this long list and then have to circle the ones that are common terms, which to me is really crazy. Okay? So that's offset multiplication. All right, now, okay, this is the next part. And it's a little bit small. Let's see if I can make this larger. View. It's already at 200. Let's try 3. Alright, here we go. Alright, if you're factoring binomials, you're looking for a common term, either a common number or a common variable. All right, an example. Suppose that I gave you 6x cubed minus 3x. Yes?
You can take 3x.
I'm sorry?
You can take 3x out of
You can take a 3 and you can take an x out. See that you can take a 3 and an x. So when you take the 3 out and the x, what will be left? Well, what do I multiply 3x by to get 6x cubed?
2x squared.
2x squared.
Minus
And what? And then minus 1. Now, that x squared minus 1 looks like a difference of squares, doesn't it? Okay, I was gonna do this a little bit later, so let me ask you. Is 2x squared minus 1, is that a difference of squares? The answer is yes, it is. Because this is the square root of 2x plus 1 and the square root of 2x minus 1. So technically, it's a difference of squares. Are they perfect squares? The answer is no. All right, and most of the time when you talk about difference of squares in Algebra 1, you're talking about perfect squares. In Algebra 2, you should know that this is square root of 2 times square root of 2. Right? And so this actually is a difference of squares. Okay? Now, I'll give you one more just to introduce this. Is that a difference of squares? Answer is yes, it is. Because this is 4x minus negative 25. I'm sorry, I didn't. It's 4x minus negative 25, and you should know that the square root of negative 25 is 5i. I is the imaginary number for the square root of negative 1. And so this becomes 2x plus 5i and 2x minus 5i. So technically, that is a difference of squares, but it's not a real number. Okay, just something to keep in the back of your mind, that as you go up in complexity from Algebra 1 to Algebra 2 to Algebra 3, you're going to pick up some other values which are technically differences of squares, but they're not what we're used to seeing with perfect squares. Okay? All right, now, okay, we're gonna go to the textbook. All right, this is the homework assignment for this week. We're going to go to finish section 7.4, and then we're going to go to 7.5 and 7.6. All right, so get your textbook out. And turn to page 341. 341. All right, 341 at the top of the page. Problem number 40. Now 40 is a really simple problem because it has 1x squared and then plus 11x plus 18. So what are the factors of 18? 6 and 3, right? 2 and 9. All right, the factors of 18 have to add up to 11. Has to be 2 and 9. So that makes this x plus 2 and x plus 9. Okay, now why do I need that? We need that because we're going to end up with some rational equations that would look like this. You're going to have that fraction, and you're going to be asked to simplify it. Right? So the first thing we have to do is we have to factor the trinomial into x plus 2, x plus 9 over x plus 9. Okay? X cannot equal -9, but these two cancel out. And so that is going to be the equation x plus 2 with a whole at -9. Make sense? So what we're doing is that we're talking about factoring so that we can get into working some really crazy looking fractions and simplify them. All right, question on that problem? All right, so again, what is the factoring for? The factoring is to have a skill that you're going to use when you start simplifying rational fractions. Okay? All right, so let's look at 46. Okay, what do you see in 46? Say again?
There's only 2 terms.
All right, 2 terms. Okay, so if it's not a difference of squares or we can't factor something out, then we can't do very much with this. So what do you see as a common factor?
X squared.
All right, both of them have an x squared, and they both have a factor of 7. So that means I'm going to factor 7x squared out. What's left? X squared minus 4. Now, is x squared minus 4 difference of squares? So therefore, the factors are 7x squared times what? X plus 2, x minus 2. That's the difference of squares here. So you're going to have 7x squared times x plus 2, x minus 2. Okay? All right. Look at 54. Okay. Do you know how to tell whether or not a number has a 3 as a factor? Add up the digits. If the digits are in the 3 times table, the sum of the digits is in the 3 times table, it has a factor of 3. If the sum of the digits are in the 9 times table, it has a factor of 9. So, when you look at 81, what's 8 plus 1? 9. That's 9 times something. Look at 101. Add the digits. 101. 1 plus 1, or sorry, not 101, 108. 108 is 1 plus 8, which is how much? 9. Therefore, it's 9 times something. It has to be 9 times 12. And what about 36? 36. Add 6 and 3. What do you get? 9. So therefore, it's 9 times what? 4. So all of these have a factor of 9. That's where you start. And then when you're done, hopefully you can factor the remainder. All right, we need to look at that one. All right. By the way, I hate that. That's terrible. Okay, so if we take 9, we have 9x squared plus 12 plus 4. All right, what do you see here? See perfect square? 9 and x squared are perfect squares, yes? Yes. Okay, say yes. Okay, what about this? Perfect square. So, let's see whether or not this is 3x plus 2 quantity squared. Alright, the inside is going to be 6x, and the outside is going to be 6x. What's 6x plus 6x? It's 12x. So that means that it was a perfect square, and the factoring will be 9 times 3x plus 2 squared. All right, that's number 54. All right. All right, 64. Problem 64. All right. What this is asking you to do is look for perfect trinomials. In a perfect trinomial, the middle term is 2 times the square root of the third term. So do you see the 25 in problem 64? What's the square root of 25? 5. What's 2 times 5? 10. So that means x squared minus 10x plus 25 is x minus 5 quantity squared. So I have x minus 5 squared minus y squared, which is the difference of squares. So, x minus 5 plus y times x minus 5 minus y becomes the 2 polynomials that equal that middle term. All right, so that's what those 4 problems. That's what they're asking you to do, is to remember that a perfect square has a middle term that's 2 times, because there's 2 of them, one inside, one outside, of the square root of that last term. All right, now let's turn to top of 342. All right, top of that, on number 76. See, I'm trying to see what they're asking us to do here. All right, if you look at the first 2 terms, what do you see as a common factor in the first 2 terms? On number 76, do they have a common factor? How about they both have x squared, right? I'm not sure what they want us to do with this one.
That's what I say to all of them.
Yeah, I know that. Well, it'd help if I looked at the answer to the correct problem. Okay. That's weird. I took the wrong side. Okay. Common factor 25 and 110 is a 5 in it. All right, I'll have to look at that one. I wasn't ready for that one. My bad on that one. 78. Okay, it says x squared plus x plus 3. But I don't know why.
You're looking at 78. You're looking at 78.
Yes, I was.
We're looking at 76.
I guess that's set up only to set up the difference by splitting. I don't know how to do this. All right, we're going to move on. I'll find out. Okay, next part, long division. We got to get to that. What was that?
It's an tank.
It was good.
Okay. All right, long division is the next part. All right, and for this, I've got to show you how long division works. Okay, if you have let's say that I'm going to take, and I'm going to do a different one, so I want you to write this down.
That one's not in the book.
I know it's not in the book, that's why I want you to write it down. All right, we're going to take 2x minus 5, and we're going to divide it into 6x cubed plus 4x squared minus x plus 3. All right? Now, whenever you do long division, you have to take this number and multiply it by some value and end up with the first term underneath the divisor. So, what do I multiply 2x by to get 6x cubed? I have to multiply it by 3 and an x squared. Okay? Got that? Now, you're going to go ahead and multiply. 3x squared times 2x is 6x cubed. And then negative 5 times 3x squared is negative 15x squared. Now, what do we do in long division when we get this number? What do we do normally back when it was just regular numbers? We subtract, right? Don't subtract. Multiply everything by negative 1 and add, because you won't make as many mistakes. So what I'm going to do is I'm going to multiply by negative 1. This will become negative, this will become positive. Now I can add them and I'll make less mistakes. 6 plus negative 6 is 0, I knew that. 4 and 15 is 19x squared. Okay, I'm going to change this problem so that the number works a little better. Change that to 5, so this is 20.
Can we do that?
Yes, go ahead and do that. Now, the reason why is I made the problem up, but I don't want to use a fraction here.
I see what we're doing.
Okay, all right. So, now, what do I multiply 2x by to get 20x squared? 10x. And it'll be positive, so it's plus 10x. And that'll give me 20x squared minus 50x. And I'm going to make this a 2, so that, again, the math works out. All right, and then you'll just continue going across. So now I'm going to go minus and plus, and I'll get 0 here, and I'll get 48, right, which will make this a plus 24. Right, because 24 times that is 48, and then 24 times 5 is negative 120, and the plus 3 is negative 117, and this is what happens. Because the answer is negative 117, it's going to be negative 117 over 2x minus 5, the divisor. So the remainder that you get, if it doesn't come out with a remainder of 0, is that remainder goes on the top of the fraction, and then the divisor goes on the bottom of the fraction, and you are finished. So this is the long division. Now, one of the problems that we had in the SAT practice, they wanted to know that you recognize that this was negative 117, and that was the difference in the answers. And so it was negative 117 over whatever the divisor was. Okay, so what happens? This is long division. Why is it used? If a number cannot be factored, you can always do the long division on it. Yes?
What's under the 117?
No,
No, the 117 over there.
Here,
Oh,
Yeah.
this is 2x minus 5.
Oh, I couldn't read it.
Yes. It's 2x minus 5.
that's a little confusing.
It's a little confusing, okay? Let's make it easier. Let's make it easier. Okay? Whoa. Do them again. Wake up. Okay, so if I'm going to take 4x plus 1 and divide it into here, right? This is x squared. Because there was no term here, I had to put a 0 there. Now, what do I multiply 4x by to get 8x squared? 2x. So there's my 2x. So 2x times this is 8x squared. And then 2x times 1 is plus 2x. Okay, what do I do next? Multiply by negative 1. This is negative, this is negative. When I add these two, I get 0. When I add these two, I get negative 2x. Right now, again, I made up the problem. What do I multiply 4x by in order to get negative 2x? It's negative 1/2. Because it's half of 4, right? Okay. So
Negative 0.5, or would you?
you could use negative 0.5, but I use fractions.
Okay.
Yeah. So that makes this negative 2x and this minus 1/2.
I missed something. How did you get minus 1/2?
Negative 1/2 times 1. See, I took negative 1/2 times 4x. That gave me negative 2x, half of 4, negative 2. And then I took negative 1/2 times 1 and got negative 1/2.
Where did you get half to begin with?
In order to be able to take 4x and end up with this 2x, I had to multiply by half.
And it's a negative.
Negative and negative because this was a negative sign here, and so that's why it was negative 1/2. Now, when I subtract, now again I'm going to have to do opposite, so I add and add. And now what's my remainder going to be? 5.5 or 5.5. So it's plus 5.5 over what, Sydney? Over what?
4x plus 1.
Very good. Over 4x plus 1. And all of them are like that. It's a skill that you have to do to prove you can do the skill. Okay? All right, that's long division. Most of the time, the long division problems that you end up doing are going to have a 0 remainder. But that's not until you get to Algebra 3. Okay? Yeah, what's happening? There we go.
Wait, is there an algebra 3?
There's what?
Is there an algebra 3?
Oh, yeah, Algebra 3 and Algebra 4.
Is it?
What?
Algebra 4, I think now is called pre-calculus.
Oh,
All right?
okay.
Okay.
There's no such coordinates.
All right.
I feel like they changed the courses.
They-
It's not on
well,
I do remember
They've done a lot of changes in it. See, what you have to recognize, and this is what we're learning in the SAT practice, is that most of the testing is going to be on the border between Algebra 1 and Algebra 2. With just a few exceptions of, there's some Algebra 2 stuff that you're supposed to know, especially those that deal with geometry. All right, and then after that, all the rest of it is really, you start over from scratch in your freshman year in college. Freshman math is Algebra 2 and Algebra 3. And one of the things you have to do in order to be able to graduate from high school is to pass a class in Algebra 2. And so you end up starting right back there again with your college level class. But when I was in high school, my last year, my senior year, I took solid geometry, Algebra 3, Algebra 4, and pre-calculus. I had 4 math classes because I had planned to be a math teacher. And so there was only, I think there was like 6 people in 2 of those classes because it wasn't necessary to graduate. But what it did is it prepared me for when I got to my freshman year in college. I had already had everything that was in the freshman math. I'd already had it. Everything that was in physics I'd already had. In fact, we had the same book in high school, my senior year in high school, that I had as a freshman in college. It was the same book. Right? And so those things overlap and repeat. That's one of the reasons for this dual enrollment, is that because they overlap, as long as you are good at it, then you don't have to do it twice. You can do it once and then move on to the next higher level. That's what you're trying to overcome. It's not simple, but it is fair. It helps a lot. Okay? What time is it? 7. We're a few minutes. Okay. I'm mad at myself that I didn't look at that last section that I had to skip.
I'm reading that too.
Yeah, I know, you're just wondering. What?
I wrote down the problem that we couldn't solve.
Yeah.
I'm gonna figure it out.
Okay, all right, so let me go back. There was something that I wanted to do as a review, if I can get there. You see chapter 6, review? I don't see it. Here it is. Okay. All right. Properties of exponents. All right, whenever you have a product, what do you do with the exponents? Say add. You add the exponents. Whenever you have a quotient, what do? Subtract them. When you have a power of a power, that's when you multiply. I did some grading last night, and several people got those wrong. They had this situation and they added them.
It gets confusing, honestly.
No, well, yes, it is confusing if you don't know it. If you know it, it's not confusing. Therefore, you have to learn it.
Okay, I'm going to take a picture of it. So.
Okay? Now, all right, this one, the power of a quotient, you're going to have to multiply the n times the a, and then subtract it from the n times the b. All right, and this was the problem that was on the homework assignment that a lot of people got wrong. And then negative exponents, what do you do with a negative exponent? All right, you've already taken a picture of that, haven't you? You already have that.
Yep.
That was on that sheet. Okay. All right. Okay. Negative exponents. Look at what I write. This is how I teach this. Negative exponents talk about location, not sign. A negative exponent is not talking about positive or negative. It's talking about the location that it is in the fraction, either top or the bottom. You get rid of the negative, move it to the other side of the fraction. Okay? Now, this is another one that comes up, and it's important. Whenever you have a fraction in the exponent, the fraction is the root. It's the index. It tells you what root it is you're dealing with. This is the exponent on the base. So this will be the nth root of x to the e. All right, there was a problem on that. That was so small I couldn't even read it. Okay, scientific notation. Okay. Whenever you have scientific notation, what does this mean? It means take this number and do what with it?
Move it.
Move the decimal point 17 places. Okay, in the problem that I gave you, how many numbers do you have to jump here? 2. You have to jump the 1 and the 3. So how many zeros do I have to add? I've got to add 15 more zeros because I jumped these 2 numbers. Now, most of the time when you're using scientific notation, when you first learn, this is a whole number. And so if that's a whole number, whatever that exponent is, that's the number of zeros I have. But that's not happening anymore. And people were making mistakes because they were using an old rule based on what you were presented as far as the mantissa was concerned. If the mantissa has extra numbers in it, then you're going to move it 17 places, not 17 zeros. The same thing would be true here. All right, I'm going to move it what? 6 places, right? I have to jump the 4, and so I'm going to put 5 zeros in front of the 4. So I'll move. Where'd that go? How do you do that? Where'd that go? That's weird. There it is. So I'll have point, and then I'll have the 5 zeros, and then 4, 5, 6. Okay. Now, if you multiply, and you end up with this, this is too large. So if I reduce this by 1 power, I have to increase that by 1 power. So it becomes 2.3 10 to the 9th. This one is too small. So if I increase this by 1, I have to decrease this by 1 so that it stays the same. And so this will become 4.5 10 to the 4th. Okay? Okay, last part. That's this one here. The red and the blue are exponential functions. This is an exponential function when the base is less than 1 or when the exponent is a negative. Because what does a negative exponent do? It throws this number to the bottom of the fraction, which would make it less than 1. So if I had a negative exponent here, negative x, then that would be 1/3 to the power of positive x, which will make it look like the green. Okay. All right, that is it. We are done unless you have questions. All right, and I will deal with that, the problem I skipped, we'll talk about next week. All right, good, thank you.
Thank you.